My name is Linda Newstrom Lloyd, and I'm a botanist. I study flowers, and I study the insects that visit flowers, and the honeybees are kind of dominant these days, and Manuka is kind of dominant these days. So we're here to support the Manuka farming, and we're a project that started in 2009, so we've been going for a little while. We started out with doing little regional guides in 2009 of what were the best plants for that you could plant for bees to feed them. So now we've continued along. We've been supported by the Sustainable Farming Fund of the MPI, and we focused on our first 3-year grant on bee nutrition, and our second 3-year grant getting it out on the farms, how to do that, how to make it match the farming operation. Because the farmers don't have much of an incentive to plant unless they're planting for another reason. So if you're doing erosion control or riparian or anything else like that, then you could just, instead of plant this plant that'll actually feed the bees. And then we did a 1-year project with the Nati Bees, which Willie Ka just spoke with two speeches ago. And that was to try to meet the challenges. I'm going to talk about that project in my talk today. And finally, our current one, 2016 to 2019, we've just completed 1 year. We've got 2 more years to go. It's more about consolidating the last 6 years of information into a flowering catalog, a pollen atlas, a willow identification guide, and booklets on how to plant for Manuka and for riparian and different things like that. There's going to be 3 booklets, and then also training. We're involved with about 3 companies where in New Zealand, the Manuka farming is one of them, in which we're trying to teach all the principles of what we've learned on how to do this and how to do it well, and then they go out and can do the same thing. So we're here to support. We're here to do the support plants that are going to be put in for Manuka honey plantations. I'll be talking about flowering calendars, how to select plants, a little bit about how many bees you should be putting on the land, because that's a very pertinent issue to see what you're going to get, what kind of honey you're going to get. And just the general question, is Manuka farming and is Manuka honey industry a sustainable industry in New Zealand? So what I'm going to do is just show you some of the key issues that you need to know about the bees and what they need and what we can do for them that'll help you optimize your bee health, which will optimize your honey harvest. This is a bee life cycle. In the winter, as Johan was talking about, you only have about 10,000 bees in that hive because they reduce their population for the winter. And you, as the beekeeper, has the job of trying to get his bees and the landowner together, try to get the bees to build up. You need to get up to about 60 to 70,000 bees from August, September, October, November. As soon as your Manuka is starting to flow, you don't want to be building up your bees. You want them to be getting their surplus honey and having your full population of bees out there to get that honey in. So the job here is to build up from your 10,000 to your 60 or 70 or 80,000 bees so that you have enough bees to go and get the honey harvest, okay? So as soon as you've got that build up, then they collect the honey for you, and then there's a few considerations on that which I'll go over. And then as the autumn rolls on, the bees start to decline. The queen stops laying so much, and everything just starts going down back to that 10,000 approximately population of bees that are going to get through the winter. So what we need to know about then is basically what we're concerned about is what have the bees got to feed in the spring, which is when they're building their brood and they need tons of pollen. The summer don't worry about, except that you don't want anything competing with your Manuka. You don't want the Manuka diluted by other plants that the bees prefer another different nectar, right? You want your bees to go onto the Manuka in the summer. And then in the winter, you want to have enough good protein in the pollen. You want to have enough good nectar to get the bees, because you've taken away all that honey, right? So they got to get that honey back up for them, because that's their stores for the winter. They got to get the honey back up, and they got to build strong, protein-rich new adult bees. That in the summer the bees only need to live for 9 weeks, but in the winter they need to live for 3 months. So you've got to build bees that are going to get, if they're weak because they haven't had enough protein, they're not going to be able to get through the winter, and you will have a dead hive come spring. So we've got hunger bees, and we just remember we're worried about the spring, and we're worried about the autumn, and we're not worried about the summer. There's tons of flowers that flower, different species of plants that flower in the summer. You don't have to worry about that. But another thing that has happened now with the growth of the Manuka industry is that it's been a bit of a gold rush, and we've gone in 2005. This is a 70-year diagram of the bee population. This is the number of hives, this red line, and this is the total number of apiaries. We're not worried about the total number of beekeepers. You can see that we're at 7,000 beekeepers, so that's not a problem. But this is the problem. We've gone from, in 2005, we had about 300,000 hives in New Zealand. And by 2015, which is 10 years later, we have 700,000 hives. So you've doubled the hives, but have you doubled their food? And we have not. We haven't doubled the beekeepers. There used to be 7,000 beekeepers way back, 70 years ago, and now we're back up to 70. It comes and goes. This little dip, that last dip, was from the varroa. Everybody got out of it. It was too hard to do. Now everybody's back into it because of the Manuka. And that's not a problem, except that we have in New Zealand 7,000 beekeepers to look after the 700,000 hives. And there's other countries like Turkey, Poland, Italy, Spain, California, about the same size as New Zealand, and they have almost 1 million hives. But Italy has 75,000 beekeepers to look after that many hives. So New Zealand has gotten very big very fast. I'm talking about beekeeping operations, okay? So it's gotten very big, very fast, very corporatized. And that's not a problem, except that the food hasn't caught up with it. That's why we're here helping Manuka farming to make sure that as you plant more Manuka and get more hives out there, you've also taken care of spring and autumn feed. It's as simple as that. You have to take care of the food just as in human nutrition. The bees, if they are not fed well, they'll have low resistance for pests and diseases. If you put too many hives on, there will be bee wars, where the strong apiaries will come to the weaker hives in other apiaries, hopefully not yours, and they will rob out. They will overtake the hive and they will rob all the honey away, because they'll smell the honey when it's too close by. And another point is that the other thing that happens within too many hives, the large number of hives, is that because there's not enough flowers out there for the natural pollen and nectar that the bees normally live on, we have to feed artificial or supplementary feed. So pollen patties and sugar syrup are required to be able to get this many hives. Now, it's not to say that those kind of artificial foods are bad, because they are needed. They're emergency rations when the weather's bad. If it's raining for 2 weeks and you don't have enough pollen in the hive, say it's early spring, you need those pollen patties. You need those supplements. But if it's, their steady diet the whole year round because there's not enough food anyways, that's a different story, a completely different story. So the nutrient deficiencies are a worry, because we don't know that much about bee nutrition, and we don't know we know they need diversity in their pollen, but we don't know exactly all the nutrients. And on the other end of it, we don't know what nutrients that there could be in artificial food that is in excess of what bees need, just like in human beings. If human beings have too much vitamin A or vitamin E, bad things happen. So on both ends of that spectrum, you've got a problem. Well, we have a potential problem. No, it's not measured, it's not studied yet. It's just that's what the underlying principle is of feeding the bees. Their natural diet is the better diet, but you need the emergency rations for certain times, otherwise you're going to lose the whole hive. So you have to play with that in a way that they get the best of both worlds. That fresh natural pollen is their natural diet, and the nectar is what gives them energy. That's their natural diet. So when we're thinking about Manuka farms, yes, we know about spring buildup. Yes, we know about autumn prep, but the other thing you've got to think about is that the bees also need some pollen during the Manuka flow. And I'll show you why in a minute. But first, I'm going to talk about the most simple tool that you can have in order to plan how to get best nutrition for your bees. It's a simple flowering calendar. This flowering calendar here is the one that we have published on our website, and it's a flowering calendar of spring to summer flowering at the national level, taken out of the flora of New Zealand. It's not your local flowering, so it says, tree fuchsia will go from June to January, but maybe in your area it's only going for part of that time. And it'll be sooner up in the north and later in the south. So this is Manuka or Kanika. The Manuka is your target plant, so you know when that flowers. And then these are the plants that flower before, and these are the plants that are flowering after. And you don't want these plants that are flowering at the same time, unless it's going to give pollen and no nectar. And then you continue on for the autumn. So that flowering calendar you can make up for your property, and it's the best way to look at how to feed your bees. It's just to make a simple flowering calendar. It's just a list of species and then the months across the top, and you fill in tick for whatever it is whenever they're flowering. So now, out of that flowering calendar, out of that big list of plants that we say are good bee plants, we've already determined that with our research, the good bee plants, we know when they flower, which ones are you going to pick? And let's consider first the Manuka flower. We know that honeybees take the Manuka nectar. That's how we're getting the Manuka honey. But the honeybees, you'd be hard-pressed to find a honeybee taking pollen from a Manuka flower. If you ever find that happening, please email me and tell me, because I haven't seen it yet and I've been looking for years. So they don't prefer to take that pollen themselves. I mean by taking the pollen, the bees are not harvesting the Manuka pollen out of those anthers and putting them in their little pollen baskets to take back to the hive for their brood. And my hypothesis of why that happens is because it's just too much work for them to get it. Tiny pollen grains and tiny little nectars, and there's other plants that have way easier to get pollen. But the native bees, they take pollen. And the native bees do a really good job. They pack their pollen dry. If they're very different, they behave differently. That pollen falls easily into the nectar. That means that pollen is a very good indicator of what kind of honey you got, because the Manuka pollen will be in it, because it falls into the nectar. And so let's look at the pollen source during the honey flow. We think that we've been working with Nati Bees now on a project, and really the best thing to think about when you're building up your land, depending on what kind of farming system you have, would be the native plants, because then you know you're not propagating weeds, which is something you need to worry about. So we like to stick to the natives, but there are farms where it's fully grazed and there's no problem. There's no native bush around. We don't need to worry so much about weediness of the exotic plants that we plant. You don't want to plant any toxic plants. Some regional councils are actively planting Caraca, which is toxic to the bees. It'll kill them. and they're actively planting tutu, which is toxic. The honey actually kills humans. So, and Ko-Fi, sometimes it makes the bees kind of drunk, and some beekeepers think, oh, it's a great idea, that's okay. Other beekeepers say, no, I wouldn't want them on Ko-Fi. So these are the main toxic plants. There are other toxic plants among exotic plants, but that's on our website, so you can see. I won't go into that detail here. What did we do on our Nati Bees program? We worked with Willie and Rangi and Maya and Rapata on a project where our problem at Trees for Bees was this. We had done a lot of work, 6 years of work, but we didn't have a way of getting the pollen from the native plants. We need to get the actual pollen from the bee out of the flower so that we know what kind of pollen it is. We can test it by having a palynologist look at it. And we get the bee out of the flower, the bee pollen. I'm sorry, the bee gets the pollen out of the flower, and then we get the pellet from the bee, and then we give that to the lab, and they tell us how much protein. We get the protein analyzed, and we're also, right now, we're doing the fat analysis as well. So we know what kind of basic nutrition the bees are getting from each type of species we're looking at. But it's very, very hard for us. We only had about 10 plants that were native plants that we ever saw the bee in the flower. The rest of the time, you know, it's too high a plant or down on a gorge. It's very, very difficult. What we did in the Nati Bees project, we decided, okay, let's the bees bring the pollen to us. So we put on, whoops, what did you do, this one? Yeah, we put traps. The beekeepers have these beehive traps that will trap the pollen. It takes the pollen off the bee legs. And so we trapped pollen and analyzed that to find out what it was that the bees are bringing in. Then we would know what native plants they're on. We had 2 palynologists, very highly trained palynologists, to identify the pollen in the pollen pellets. We also took pollen out of the honey, out of the frame. And Dr. Shun Lee and Dr. Ian Rain were the palynologists who identified the pollen, I'm sorry. So we created pollen profiles. This pollen profile is for the bee pellets, what the bees are bringing in for their pollen for their brood. And it's, at this time was November. And this is how much trifolium, and then they brought in clematis. They were on the dandelion, so you can see where your bees were. And that gives us a clue, oh, that's what the bees were on, and then we can use that information to know what plants to plant. Like, for example, Nikau palm, we were a little bit surprised, and beech, we were really surprised that the bees were on those and they were getting good pollen. And for the honey, you could see here, Shun Lee has worked out how to tell the difference between Manuka and Manuka pollen, which is a very important result that we have right now, which helps for the honey standards that MPI is doing right now. So that data has been given in. You can now tell the difference between Manuka and Manuka pollen, and she's done several years of work on that now. And so in this site at Nati Bees in Rangitukia, we had that much leptospermum, that much kunzia. We also had some heather coming in, some little bit of clover, some buttercup, and some rewa and clematis and taraxacum, and another one, Panantia. That's the pollen we got in the honey. So we know what they're doing for honey, and we know what they're doing for their pollen food. Then we take that list. I go through it as the botanist, knowing all the literature and all my field experience of what's good for the bees. And Angus, who knows how to plant on farms, where to plant, how to plant, we decide together in an iterative fashion what to plant, okay? And that's what we're teaching people to do now. We get our results from the field work and the literature, and then we get, Angus looks at the land, like sort of what Joanne was talking about. He inspects the land, he says, you know, the farm, it always works out with the farmer's operations. The landowner will know that, hey, I want a shelter built there, I want a riparian protection here, I've got some erosion over there, I want some amenity, you know, I want a pretty avenue coming into the farm, or, you know, whatever it is that you need. Angus works with that, and then designs the best plants using that flowering calendar I showed you. And then the botanical knowledge I know, like, hey, prioritize that one, not that one. And then also matching it to the climate and to the you know, the microhabitat that you have in that region that you're working in. So it really takes a team. It takes a team of, the beekeeper knows where the gaps are, the farm planting advisor knows what to plant where, the landowner knows what he wants to plant, and he'd plant anyways. If he wasn't planting bee tree, he'd be planting something else, right? And so you have a team of people, and the botanist in the background saying, hey, this one's good, that one's not, and etc. So you put it together and you get a variety of ways. We at first thought that protein, we wanted to optimize protein. We do, but by the time you filtered it through all those other considerations of what you want where, like for erosion, or this is a wet area and this is a dry area, you know, the protein is not the number one highest thing. We optimize it, but after optimizing it along with all the other conditions that we're optimizing. So you come up with, now this is a different kind of flowering calendar. This is the flowering calendar of what we planted at the Nati Bees site. So you list the plants we put in, and you give them all a score of 1. And this is a species list flowering calendar of just, I've got this many species, you want as much diversity as you can. And we had this for July, June, July, August, September, and then not very much for during the Manuka. You don't want things to compete, but you do want a little bit of pollen source. We have in here Tarata for our pollen source, and it doesn't have that much nectar that's really going to compete. Manuka, in this site, flowered October, November, December, January. Not within that range, like not all through that range, but it could start as early as October, flower as late as January. We put in some pollen source, put in tons of plants here, tons, you know, 1, 2, 3, 4, 5, 6 species that are flowering in that early spring time. And then we have 2 in the autumn for February, March. We have the Pseudopianax lawsonii, and then down here we have lacebark and Periri starts. Okay, so we've covered the time that we want to cover, and we're not, the way we're putting plants in at the time when Manuka's flowering is very calculated to give pollen and not much nectar. And for example, there's things like buckwheat, doesn't have any nectar at all. So you could have a little plot of buckwheat around, sorry, not buckwheat. I got that wrong, is it? Which is the one that gives pollen and no nectar? It's not buckwheat. Buckwheat gives a really good honey. I'm sorry, I've got a mind blank. What one was it?
Gorse.
No, gorse. Yeah, we don't talk about, here's what we say about gorse. And this is on the record. If you have gorse, leave it there. Don't take it out unless the farmer doesn't want it. But if you want to get rid of your gorse, because gorse is flowering at a time when you really, unless you've got 5-finger, you don't have too many things available. If you don't want your gorse, plant 5-finger, make sure the possums don't get all that. So you've got to do your pest control. So, and you can build bees up in the spring on 5-finger alone. But if you want to get rid of your, people say, oh yeah, get rid of gorse. And I'm looking and I go, well, I don't know what your bees are going to feed on in the early spring. So if you can tolerate it, if it's not illegal, keep it. You can't, it's illegal to go plant it. Each regional council has their own rules. So you have to follow those rules, but you have to follow common sense. And you got to look, yeah, I want to get rid of the gorse. There's a hillside that we want to get rid of the gorse at Rangatikia, but we got to get that 5-finger growing. And we got a problem with pests, goats and possums and stuff chomping on those plants. We got to solve that problem, get the 5-finger going, and get the bees building up on the 5-finger, and then we can get rid of the gorse. So it's, gorse is a very controversial plant, and our public position on that is just leave it there under legal, whatever restrictions you have in your regional council, whatever restrictions you have for your farming operation, leave it there until you can replace it. So that's why the flowering calendar is so important. Okay. So the second type of flowering calendar that you do is not just the list of species, putting a 1 in every one of those cells. See, we added up here the number of species. That's the number of species in a flower, but that's not what you want. You want to know how much flowering is going on. So what you want to do is put in the number of plants that you planted. So see what we did here. We said max out those 5 fingers because we want to try to get rid of the gorse. So we put in 35 plants of 5 fingers. And then 40 really max out the lace bark because there's not much, it's one of the best, there's not much else for the autumn. So we put in 40. So now we're calculating a new flowering calendar that's based on the quantity of each species, not just a pleasant absence of each species. And you see now we've done pretty well for our early spring, if the 5-finger will mature and do well, and the pests don't get it. But we're still a little bit low on the autumn. So we need to get out there and get more hebe and more lace bark in there. So it's iterative, you see. You play with that. You've got the flowering calendar at the beginning to know what your candidate species are, and that you just download from our website, and we'll improve that and have more candidate plants. Then you have your flowering calendar with your presence absence of species that you're going to plant. Then you manipulate it with your flowering calendar of how many plants of each species that you're going to plant. And so what should we plant? Here's the male flowers of the 5-finger. Very good pollen source. And here's the female. And you want the female plants just as much as you want the male plants because you need the nectar too in the spring. Because that's what the bees use to make wax. And they're building up their combs. This is our terata, the pollen source right in the middle of it's just one candidate. We're still working on that problem. There's lots of things that you can plant, but there's one candidate. Okay, and there's the New Zealand flax, which is the premier best plant of them all because it has so much protein. But you have to know your local flowering because if your local flax flower at the same time as your local Manuka, that has a lot of nectar. There's about 150 to 200 microliters of nectar in one of those flowers. And when there's that much, unless the birds are taking the nectar away and the bees can't get down into the flower to get it, the bees can get the nectar if it comes up to the top of that. And I've seen it a lot. So you have a problem there. And we have actually calculated to grow an adult bee, you need 125 to 145 milligrams of pollen to grow one bee. So now we can calculate, we'd like to do this for all the plants, but we can't. I mean, we haven't got the data yet. We actually weighed how much pollen came out of each anther. See, there's 6 of these anthers in each flower. We bagged them and we counted how much pollen each anther produced. Each flower produced 5 milligrams of pollen. Then you multiply up how many flowers on that plant and you figure out you need about 25 to 30 flowers of this particular flax in order to support a bee, one bee. So now you can start, I mean, you could quantify this, but that's the only one I've ever been able to get done yet because I had a student do the work. Sebastian from France did all that laborious work. It was really a lot of work to get it. But you can't, there's some like a Manuka, I defy anybody to extract pure pollen out of a Manuka flower and try and adulterate honey. I'm sorry. It'll be so expensive. It's so time consuming. It's such tiny pollen and such tiny little anthers. You're not going to be able to do it. I mean, if you can do it, it's going to be too expensive. But Sebastian spent a lot of hours, those are very big anthers, and there's a lot of pollen on every anther. You could do it with peony, kiwi fruit. They do it with kiwi fruit. So, it depends on the size of the anthers and the number of anthers per flower. Native broom has 37% protein, so that's a nice candidate. But the bees don't take the nectar, they take the pollen from the native broom, the honeybees. Or it might be vice versa. I should have said that the other way around, sorry. Cabbage trees, 28%, that's very good, but there you got to be careful that's not flower. You got to know your local cabbage tree flowering time versus your local Manuka flowering time. It could be a good source. Pohutu cow is a good source. Again, might overlap, but it's a very, very good nectar source. Well, that is a monofloral honey of its own, in its own right. Now, willow, I asked Willie and Bella just before this talk, is it okay if I talk about the willow? Because it's not a native, but we did plant it in Rangitakia in our Nati Bees project. Why? There's nothing that I have ever seen that is better to build up the bee populations really, really fast. And that's because when they're on a willow flower, they have really high protein, very good fat analysis. The lipids in the willow have lots of good omega-3s in them, which is important for the bees' immune systems, just like for humans. And at least that's one little bit of literature I've read. And they, if you watch the bees on a willow, they just scramble, and when no time flat, they've got a full load and off they go. So on a willow, it's amazing to watch the bees. So now let's just talk a little bit about how many hives, how many bees. And as I've told you, there's a problem with too many hives in this country in terms of it not balancing out with how much natural food there is. And people worried about boundary stacking, and there's lots of names for overcrowding. Overcrowding is putting too many apiaries in one area, and overstocking is putting too many hives in one apiary. So they do it both ways. We know from cows, I probably don't have to go into this in detail, we know what it's like if you overstock on cows, what's going to happen. You're going to get less milk per cow, and you're just making a very expensive, inefficient operation. Same thing happens with bees. If you overcrowd, it's just inefficient. It's, you know, you're cutting down your own profit. But what people don't realize is that this may be your land and you stocked it properly, and people have talked about this today, but your neighbors have too many hives and bees have no fences. They're going to come in. If you've got Manuka here and there's something less preferred in the other pieces of land, they're going to come and get your Manuka. What happens with overstocking? It's a bit of a no-brainer. The bees use up more honey and you get a poor harvest. It's an inefficient system. Bees are malnourished, you get more diseases. Bees are starving, the colony dwindles, and dwindles to the point you're going to have a colony loss. Dead out hives, loss of profit, because it's expensive to go trying to build that bee, get another beehive. And dead out, and then everyone suffers. It's not just the person putting the 200 hives on your boundary. Everybody's suffering, and you get a bee war with robbing, and you know, probably your bees are going to lose because they'll probably put strong hives there. And the native bees' survival is threatened. I'm very worried about in the environment. If we put too many beehives in an area for too many years, we may have, I don't know this, I'm just questioning, we may have a problem with the native bees' survival, because the honeybees don't take the pollen, so they're okay for their pollen, but are they okay for their nectar? I don't know the answer to that. But it's worth raising that question. And competition for the bees' attention, maybe you put in the best, highest value Manuka, you put a lot of money into this, and this guy's got the best something else, like clover, or the highest yielding clover that ever came, and they like clover better. The bees don't have any fences, so off they go, and you don't get your Manuka harvest. So when you're doing your planning of thinking about planting Manuka, you've got to analyze the whole area. And okay, everybody's talking about how far bees fly. Usually they fly 1 kilometer or 3 kilometers, but there is literature showing that bees are capable of flying to 13 kilometers. Barry told us that 1 kilometer is 300 hectares. I don't know how, I mean, I've seen the math before, but I can't remember the number. 10 kilometers, that's a lot. Bees can fly as far as they need to get the food they want, and they're just always, when you're thinking about the bees, just think about human nutrition. We would go as far as we need to get our favorite food, so the bees do that too. And maybe you've got a rewa there, and rewa in it is a good monofloral in its own right as well. So if you've got a huge bunch of rewa, and in your location the rewa flowers right when the Manuka's flowering, or that happens with Tauri as well, The bees, there's a heck of a lot more nectar in arroyo. It's a lot easier to get, and they're not going to bother with the Manuka. So my question, I hope I haven't run out of time. Have I? A little bit? I'm sorry. Okay. I'll make this quick. Can there be a sustainable, profitable Manuka honey industry? I wouldn't be standing here today if I did not believe there is. But if we can do it right, and we can understand what the bees are going to do and where they're going to go. This is 22 years of data from a beekeeper in the North Island. Now, it's interesting what happens. This is an average line, and this is the blue is the Manuka percent of the total honey, and the red is the annual percent of the average honey. You can see that there's some years they didn't get any Manuka at all. And there's some years where they got 50%, and some years they got above average. And this is an area where there's a clover patch right by. So how come sometimes they got no, and this relates to your question about honey flow, how come sometimes they didn't get any Manuka? It's because the clover was flowering so well. How come some years they got above average Manuka? And it's because the clover didn't yield. So whether the clover yielded or whether the Manuka yielded and how everything else that was going on and what the native bees were doing, that all goes into the mix of what is going on. And you can go out there, and the best beekeepers are the ones who look at the flowers. They look at the bees in the flowers, and they see what's going on. And they keep records like this. Here's another. And this one's in the East Coast. This is, I don't know how many years. It's real data from a real beekeeper. And they're getting the annual honey average is the red line, and the annual activity level is going down a little bit. Why would that be? There might be simple as it's overstocked, and the honey is getting diluted because of the overstocking. The bees are going to have to go farther to more plants to get enough honey. So what the controlling factors are, just in summary here, I'm finished. The bee colony feed budget and the flowering time, it's easy to do. The diversity of bee plants, you want to get as diverse as you can. The scale of the plantation hive stocking rates, you need to be aware, conscious of when you're planning to invest, what's going to happen in your 1 kilometer, 2 kilometer, 3 kilometer, 5 kilometer, and 10 kilometer radius. You don't have to worry too much after 5 kilometers, and usually you're only talking 2 to 3 kilometers, but it just depends on how overstocked that area is, or how much Manuka there is. But you see, you're doing your plantation of Manuka, and the more high quality Manuka that you plant in your area with really good spring and winter and autumn support, your bees are going to get there first because they're closer. So I think that the Manuka orchards with supporting bee feed can be profitable and sustainable. And that's why I love supporting Manuka farming, because that is going to solve the environmental problems, it's going to solve the overstocking problems, it's going to solve all the problems, is for people to plant Manuka and plant the trees for bees that goes with it, to have a nice system that will work together to keep the healthiest bees for the healthiest business. Thanks.
Thank you, Linda.
I don't know.